discussed in the previous class, preparation of polyvinyl chloride. So polyvinyl chloride, it is prepared by, means we are preparing by undergoing addition polymerization, nothing but we are adding a number of vinyl chloride molecules and using a catalyst benzoyl peroxide and applying heat and pressure, and we prepared polyvinyl chloride. It is a polymer. Okay, ma? Vinyl chloride is a monomer. Here I wrote N. N indicates number of vinyl chloride molecules we are adding, and we are getting polyvinyl chloride. Students, the structures you have to learn thoroughly. Okay, practice on the paper in the rough book. Okay, now properties. So polyvinyl chloride, it is colorless. It is colorless and odorless. It is colorless, odorless, non-inflammable, chemically inert powder. Okay, PVC is colorless, odorless, non-inflammable, and chemically inert powder. Chemically inert powder. Okay, na? Means nothing but it is resistant to chemicals. Chemically inert powder. It is resistant to light. PVC, polyvinyl chloride, it is resistant to light, atmospheric oxygen, inorganic acids and alkalis. Okay, it is resistant to light, atmospheric oxygen, inorganic acids and alkalis, but it is soluble in hot chlorinated hydrocarbons. For example, ethyl chloride. So PVC, it is soluble in ethyl chloride. Okay, it is soluble in hot chlorinated hydrocarbons such as ethyl chloride, and its melting point is 148 degrees centigrade. Melting point 148 degrees centigrade, and it is strong and brittle. Okay, this PVC, polyvinyl chloride, strong and brittle. And PVC, it is not stable to heat. It is not stable to heat and UV radiation. Okay, it is not stable to heat and UV radiation. It undergoes degradation. When it is exposed to UV radiation and more heat, it will undergo degradation. So these are the properties of PVC. Okay, PVC is colorless, odorless, non-inflammable and chemically inert powder. Okay, it is resistant to light, atmospheric oxygen, inorganic acids and alkalis, but soluble in ethyl chloride, soluble in hot chlorinated hydrocarbons such as ethyl chloride. Its melting point is 148 degrees centigrade. It is strong and brittle, but it is not stable to heat and UV radiation. It will undergo degradation.
Ma'am, PVC, you said it is resistant to light only, no ma'am. Means UV radiation is also light, no ma'am.
It is resistant to light, but come to the UV radiation. Light means not UV, no. It is resistant to light.
Ultraviolet radiation.
Ultraviolet radiation, it is not resistant,
light,
but normal light, it is okay.
Okay.
Normal light, no problem. UV radiation, ultraviolet radiation, it is affected.
Okay.
Okay, Namma? Remember this 5 point, students, you have to write these properties. Okay, when you get the question, you have to write the properties of PVC. Okay, it is strong and brittle, melting point 148, and it is resistant to chemicals. Okay, acids and alkalis, light, atmospheric oxygen. It is colorless, odorless, non-inflammable, and chemically inert powder. It is not stable to heat and UV radiation. It will undergo degradation. Okay, applications, we use rigid PVC and non-rigid PVC. Okay, we will use rigid PVC and plasticized PVC. Means we are using directly. We are after preparing polyvinyl chloride, so we won't use any plasticizers, and we go for molding articles. And after adding plasticizers, we go for different articles. We'll mold the different articles. Okay, na? So we'll see the applications. Rigid PVC or unplasticized PVC, this have superior chemical resistance, okay, and high rigidity, but it is brittle. Brittle means breakable. Okay, it is used for making sheets. Okay, used in tank linings. Say for example, take big chemical tank. Okay, so inside the tank, we will take the linings with PVC sheets. We will arrange. Okay, it is used for making sheets used in tank linings. Safety helmets also prepared by PVC that is rigid PVC, and refrigerator components also, okay, and tires, okay, tank linings, safety helmets, refrigerator components, and also tires that we are manufacturing, okay, by using rigid PVC. And plasticized PVC, this is obtained here, plasticized PVC by using plasticizers, tricrysyl phosphate, or you can take dibutyl phosphate, okay. It is used for making sheets, packing raincoats, okay, tablecloth curtains, electric cables, okay, toys, radio components, plastic coated cloth, chemical containers, okay, and we will use thermal insulating foam that we will use in cinema theaters, buildings, and aircrafts, okay. So many uses are there, okay, with the PVC, plasticized PVC. So packing raincoat, tablecloth curtains, electric cables, okay, toys, radio components, plastic coated clothes, and chemical containers, thermal insulating foam we will use like in buildings, cinema theaters, and aircrafts. So these are some of the examples I gave, okay. That is how we are using a plasticized PVC and what articles we are making, okay. Now this is the plasticized PVC. Now students, tell me, by using rigid PVC, so what are the uses are there, rigid PVC uses? Students, uses of rigid PVC, tell me where we are using.
Tank line, making sheets used in tank lining, safety helmets, and refrigerator components, tires,
refrigerator components and tires. Whereas plasticized PVC, where we are using?
Thermal insulating foams, packing raincoats, tablecloth curtains, etc.
Curtains, electric cables, radio components, etc. Okay, toys. So this is about PVC, everybody. First you have to write the preparation. This no need, you remember this one. So preparation of PVC and properties and applications. So next is okay. So next is nylon 6,6, So nylon belongs to the polyamide resins, okay. Nylon belongs to the polyamide class of synthetic polymer. It is also synthetic polymer, so which have repeating amide group. So we discussed in the previous class, okay, na? CONH, repeating amide group will be there, okay, in nylon 6,6. So nylon first synthesized in London. Nylon, it is first synthesized in London, and technology was taken and manufactured in New York. So first it is synthesized in London, but afterwards again it is manufactured in New York, okay. So after the stands for okay, New York, okay, for New York, and LON stands for London, okay. So where it was synthesized. So this polyamide resin, it was given the name nylon. So why we are calling it as a nylon? This polyamide resins or polymers means because it is first synthesized in London, nylon, and later on it was manufactured in New York. So given the name is nylon, okay. So there are different types of nylons are there, but we are discussing only nylon 6,6. So there is a nylon 6,6 is there, nylon 6 is there, nylon 10 is there, okay. But we'll take one example. So where the first number stands for the, so here, for example, nylon 6,6, this only I am telling you. First number stands for the number of carbon atoms in diamine, okay, 6 carbon atoms. Whereas the second number indicates the number of carbons in diacid. 4, 5, 6. So we have given the name nylon 6,6. So preparation already we discussed in condensation polymerization, students, so that it is prepared by taking a monomers. different monomers with functional groups, either COOH or NH2. Okay, so we prepare the polymers here by condensation polymerization. So nylon 6,6, it is prepared by condensation polymerization of hexamethylene diamine with adipic acid. Hexamethylene diamine with adipic acid. So when we are condensing these two monomers, so there is elimination of byproduct, water molecule is taking place. Along with the product, we got nylon 6,6. Now properties are nylon 6,6 possess high melting point. What is the melting point of PVC? What is the melting point of PVC? Students, on your video. Hello? What is the melting point of PVC?
148.
148. What is the melting point of PVC?
148.
148. What is the melting point of polymer? Nylon
264.
melting point of polyvinyl chloride is 148. Melting point of nylon 6,6 is 264 degrees centigrade. Due to the why it is having high melting point compared to the PVC means due to the hydrogen bonding between hydrogen of the amide group, and we can take oxygen of the carbonyl group, CONH. Okay, there is a hydrogen bonding between hydrogen of the amide group and oxygen of the carbonyl group. Following me, students? Okay, so
Yes,
we have high melting point compared to polyvinyl chloride. Polyvinyl chloride melting point is 148, whereas nylon 6,6 is 264 degrees centigrade because of the presence of this hydrogen bonding, okay, in amide, that is between hydrogen of the amide group and oxygen of the carbonyl group. Now, second point is nylon 6,6 have good strength. It have good strength and they will absorb little moisture. We will use nylon clothes. Yes or no, students?
Yes, ma'am.
They absorb little moisture. Nylon 6,6 will absorb little moisture and that will dry very easily or thus drip dry in nature. Okay, na? These fibers are flexible. These fibers are flexible and retain original shape after use. Okay, so these fibers are flexible and retain original shape after use. So these are the properties of nylon 6,6. See, some other properties are there. These have high temperature stability. Nylon 6,6 possess high temperature stability. Okay, so they have good stability nature at high temperature. Okay, they have good strength fibers and good abrasion resistance. Students, what is abrasion resistance? What I told you, this also like related to quality only, strength only. Good abrasion resistance. So what is abrasion resistance means? When we are using the material, if upper layer of the material is removed, it is going slowly, upper layer of the material. So that material will have poor abrasion resistance. Okay, if the upper layer of the material is not removing, okay, there is no removal of upper layer of the material while we are using, so that polymer will have, okay, good abrasion resistance. Next one, they are insoluble in common organic solvents like benzene, acetone, but they are soluble in phenol and formic acid. So nylon 6,6, it is insoluble in benzene and acetone, but solubility will be there in phenol and formic acid. So these fibers are easily blended with wool. These fibers are, we can easily blend with wool to increase the strength and abrasion resistance of wool. So to get a more strength material, so we can blend with wool and we can increase abrasion resistance also. Okay, na? So these are the properties of nylon 6,6. Students, what is the first property? Students, what is the first property?
High melting point.
High melting point. What is the melting point of nylon 6,6?
264 Celsius.
What is the second property? Tell me.
Good strength.
Good strength. Third property,
Little moisture.
it will
Absorption
absorb
of
little
little
moisture.
moisture.
Okay, it will absorb little moisture. It will dry very easily. Fourth point, these fibers
Flexible.
are flexible.
Flexibles and retains original shape.
Retain to original shape after using. Next point is what property?
Possesses high temperature.
It is
High
it
temperature
possesses
stability
high
and good
temperature stability.
pressure.
Okay, and also,
Insoluble in common organic solvents.
so it is insoluble in solvents like benzene, acetone, but solubility is there in, but it will be soluble in
Phenol and formic acid.
phenol and formic acid. Okay, so these fibers are easily blended with the
Wool to increase its strength.
to increase
and
strength
abrasion.
and abrasion resistance of the wool. Okay, now tell me what are the properties of PVC? 5 points are there.
PVC is colorless, odorless, non-inflammable, and chemically inert powder.
It is colorless, odorless, non-inflammable, chemically inert powder. Next, it is resistant to
Light, atmospheric oxygen, inorganic acids, and alkalis.
but it is soluble in
Ethyl chloride,
ethyl chloride. Okay, its melting point is
148 degrees Celsius.
okay. So PVC is stronger. PVC is strong only. It is strong and
Brittle.
brittle. Okay, what is the disadvantage property? Tell me. PVC is not stable to
Heat and UV
heat
radiations.
and UV radiation. It will undergo
Degradation.
It will undergo degradation. So this is about PVC properties. So nylon 66 I gave 7 points. Okay, now first is melting point. Second is good strength. Okay, and PVC also it is strong polymer. So this is also having good strength. So this will absorb little moisture. So there you can write in PVC, it is a colorless, odorless, chemically inert powder. It is resistant to oxygen, light, and it is resistant to acids, alkalis. And third point, you can write melting point. So there, fourth point, you will write it is strong and brittle. But fifth point, you can write it is not resistant to heat and UV radiation. It will undergo degradation. So whereas in nylon 66, first you write melting point to 264 degrees centigrade. Second, it is having good strength. So they absorb little moisture. These fibers are flexible. Okay, na? This have high temperature stability. Okay, good abrasion resistance. So they are soluble in phenol and formic acid, but they are insoluble in benzene and acetone. And last point, compulsory you have to write these fibers easily blend with wool to increase the strength and abrasion resistance of wool. So applications. So this nylon 66 is used for fibers which find use in making socks. Students, you can see, you will wear the socks, no? Yes or no?
Yes, ma'am.
That are made by the
Nylon
66 socks. So then also we will take the ladies' hoses, undergarment dresses, carpets, everything we are making with nylon 66 only. Okay, and also it is used for making ropes, filaments for ropes. Okay, filaments for ropes, bristles for toothbrush. We will use the toothbrush. Is there no? Students.
Yes,
Hello.
ma'am.
That bristles for toothbrush. So that are made by the nylon. Okay, that are made by the nylon 66. And tire cords also it is made by the nylon 66. So write students for making socks, ladies hoses, undergarment dresses and carpets. And also it is used for making filaments for ropes. Okay, and bristles for toothbrush and also tire cords. So these are the applications of nylon 66. See, I gave, okay, here you can see, okay, what we are making with nylon 66. Okay, nylon stockings, parachute cloth colors, this also with nylon 66, seat belt, ropes, sleeping bag, everything with nylon 66. Okay, na? Hose pipe. So this is about nylon 6/6 ma. Preparation you have to write. Students, this theory part no need. I am telling you this and all no need. Okay na? No
Yes,
need to
ma'am.
write. You have to write only preparation. Okay, only preparation, properties 7 points, and write applications. PVC application is different, nylon application is different. PVC property is different, nylon property is different. Following me?
Yes, ma'am.
You have to remember properties and applications. Anyway, you will learn preparation, but you have to, don't confuse, you have to remember properties, okay, and you have to remember applications. Okay, tell me rigid PVC application 2.2, you 2 example you tell me. Rigid PVC. Rigid PVC 2.
Tanks,
Huh?
and, helmets,
Tanks, chemical tanks,
helmets.
helmets.
Refrigerate,
Plasticized PVC 2, you tell me. Plasticized PVC. Any 2. Plasticized PVC.
table,
Table.
tablecloth,
Tablecloth. Tablecloth what? Tell me. Plasticized PVC, what all we can go?
curtains, and electric cables.
Tablecloth curtains. Remember cables, ma. Electric cables. Okay. Electric cables, tablecloth curtains, packing raincoats. Okay. And radio components, chemical containers. Okay. All this you can write. Plasticized PVC. Tell me again, repeat. Repeat.
Electric cables,
Hmm.
toys, radio components, etc.
That 3 you remember. Electric cables, toys, radio components. Any 2? 2 more? Packing?
Packing raincoats, tablecloth curtains.
Packing raincoats, tablecloth curtains. Okay. So this you remember, ma. Plasticized PVC. Now nylon 6/6 application you tell me. Nylon 6/6 application.
Filaments for ropes, bristles
Okay.
of
Filaments for ropes. Just ropes also you can write. Ropes, bristles for toothbrush, and tire cords. Okay. Example. And making socks, ladies' horses, undergarment dresses, carpets. All these are applications of nylon 6/6. Now, preparation properties and applications of Teflon. Applications of Teflon, or it is called polytetrafluoroethylene. Polytetrafluoroethylene. So we are taking tetrafluoroethylene and we are adding benzoyl peroxide catalyst and applying heat and pressure, and we can prepare polytetrafluoroethylene. Polytetrafluoroethylene. So this is prepared by addition polymerization process. Okay, na? So Teflon is obtained by addition polymerization. Okay, polymerization of tetrafluoroethylene molecules in the presence of benzoyl peroxide as catalyst. Okay, so this example also already I told you in addition polymerization. Okay, so we can take. Okay, so thermoplastic resins that I gave you as example. Okay, polyethylene, polyvinyl chloride, Teflon. Okay, and you can take polystyrene. These 4 examples you can take in thermoplastic resins. Okay, so this is prepared by taking n number of tetrafluoroethylene by adding together and going for polymerization process by applying heat, pressure, and catalyst. So where we get the polymer polytetrafluoroethylene. Polytetrafluoroethylene. So it is named as Teflon. Okay, na? Next, properties. So these are having some different properties. So due to the presence of highly electronegative fluorine atoms, you can see in the polymer Teflon. So due to the presence of highly electronegative fluorine atoms, so results in very strong attractive forces between different chains. So there will be more attractive forces will be there between different chains. So these strong attractive forces, this give gives the material extreme toughness. So we get very tough material, okay, extreme toughness. So they will have the high melting point. What is the melting point, students? What is the melting point of Teflon?
350
Polytetrafluoroethylene?
degrees
350
Celsius.
degrees centigrade. Polyvinyl chloride?
148.
148. Nylon 66? Nylon 66 melting point.
268, I suppose.
Kaadu. No. What is the melting? Huh?
250.
No.
56.
No. What is the melting point of nylon 66?
264.
264 degrees centigrade. Because of the here there is a hydrogen bonding between a hydrogen of amide group and oxygen of carbonyl group. Now tell me, what is the melting point of Teflon? Teflon.
350 degrees Celsius.
350 degrees centigrade. Okay. So it is, we are getting very tough. Okay. It is having extreme toughness, high melting point. Why it is having high melting point and extremely tough material we got? Why, ma?
Highly electronegative fluorine, ma'am.
Because of the presence of highly electronegative fluorine atoms. So it will have very strong attractive force between polymer chains, between different chains. So this strong attractive force, it gives material extreme toughness, okay, ma, having high melting point, 350 degrees centigrade. So it is having high chemical resistance, ma, high chemical resistance to all, towards all chemicals. Okay, it is having high chemical resistance. So except like you can take hot alkali metal, hot fluorine, except that it is resistant to all chemicals. It is having high density. It is having high density 2.1 to 2.3 gram per cubic meter. What we see? CC means what, ma? Centimeter cube. Centimeter cube. Gram per centimeter cube. So it is having high density, 2.1 to 2.3. Whereas if you take other polymers, it will have low density. Like polyethylene, it will have low density. But compared to, means when we come to the Teflon, it is having high density, 2.1 to 2.3 gram per centimeter cube. What is density means what, ma? Students, what is density?
Mass by volume.
Mass by volume. So it is very strong, hard polymer. You know already, it is strong and hard polymer. And that can be machined to drilling, punching. That can be machined to drilling, punching. Okay. So this is a hard polymer we can use. Okay. That can be machined to drilling, punching. Okay, etc. It is very good electrical insulator. It is a good electrical insulator. Okay. It is a good electrical insulator. Very good electrical insulator. It possesses very good abrasion resistance. This polymer Teflon, it possesses a good abrasion resistance, good electrical insulator. It is strong and hard polymer having high density, and its melting point is 350 degrees centigrade because of the presence of high fluorinated, highly electronegative fluorine atoms, where strong attractive forces will be there between different chains. Now students, tell me what are the properties of polytetrafluoroethylene, ma? 5 points are there. Simple. What is the first point?
High melting point.
High melting point. What is the melting point?
250 degrees Celsius.
350 degrees centigrade. 350 degrees centigrade. Okay, ma. Why it is having high melting point? Why we are getting very tough material?
Due to highly electronegative fluorine atom.
Due to the presence of highly electronegative fluorine atom, there will be more strong attractive force will be there between different chains. Okay, na? So what is density here? Material.
High density.
2.1 to 2.3 gram per cubic centimeter. High density it is having. And next it is strong and
Hard
polymer. So it is having, what property it is having? Fourth point.
Good insulator.
good insulator, good electrical insulator, then it possesses
Very good abrasion resistance.
very good abrasion resistance. Students, what is abrasion resistance? I told you already. What is abrasion resistance?
Removal of top layer or something. After a few. Removal of top layer.
Removal of top layer from the material. Okay, na? So after using for a few days or okay, if removal of upper layer of the material is taking place, that polymer that is having poor abrasion resistance. If there is no removal of upper layer is there, then that is having, it is possessing good abrasion resistance. So applications, I gave some points here. So Teflon, it is a very good, okay, insulating material. Okay, so we can use for motors, transformers, cables, wires, etc. You can see the wires, cable wire. So Teflon, it is having a good insulating, it is a good insulating material. We can use for motors, transformers, cables, wires, etc. It is used for making gasket. You can see gaskets. Students, you can see. Hello. You can see the gaskets.
Yes, ma'am.
We will use in pressure cooker. Rubber pipe, round one. Hello.
Yes, ma'am.
Yes or no?
Yes, ma'am.
We will use in pressure cooker. We will use in engines, gaskets. So in making gaskets, pump parts, okay, na? Tank linings, in tank linings we use, and also in tubing also, okay, we will use the Teflon. And due to its extreme chemical resistance, so we will use in chemical carrying pipes, and we will use in non-stick stopcock for burettes. I gave some here. You can see everybody, students, here. Stopcock you can see in burette. So this is made by, students tell me, this is made by
Teflon.
Teflon. This is made by Teflon. So non-stick stopcock for burettes and non-stick cookware products. What is this? Pan. What we are using on the pan? What we are giving the coating? Uses of Teflon. Okay. So we are taking non-stick cookware products, example pans. That is also we are taking a Teflon. Okay. So these are the few applications I gave you. Teflon. Okay. So remember this, we will use in motors, transformers, cables, wires, and gaskets, pump parts, tank linings, and chemical carrying pipes, non-stick stopcock for burettes, and non-stick cookware products. So I gave some application part, Teflon. Remember. So for each polymer, synthetic polymer, you have to learn preparation, remember properties, and write applications also. Learn applications also. Now tell me, students, what are the properties of nylon 663 properties? You tell me. At least 3 properties.
High melting point of 250 degrees Celsius.
In 3 polymers, what we learned now, tell me melting points of PVC, nylon 66 and Teflon, tell me.
148.
148 what?
PVC for degrees Celsius for PVC.
PVC. Okay. Next, nylon 66 melting point.
264 for nylon or 6.
Teflon?
350 degrees Celsius.
350. Okay. So now Teflon, why we are having high melting point? 350?
Highly electronegative fluorine atoms.
The presence of highly electronegative fluorine atoms. Okay. So now tell me density. It is having high density.
2.1 to 2.3 grams.
gram per cubic centimeter. Okay. Now, Teflon, it is having good abrasion resistance. Good abrasion resistance, ma? Teflon. Yes or no?
Yes, ma'am.
Then nylon 66 also, it is having.
Abrasion.
ఇక్కడ చూడండి అమ్మ. See here, it
Abrasion
is having
resistance.
good abrasion resistance. So in both the nylon 66 and Teflon, it is having good abrasion resistance. Now PVC is it is resistant to
Light, atmospheric oxygen, inorganic acid and
acids
alkali.
and alkalis, whereas you can take Teflon, it is also having high chemical resistance. Yes or no?
Yes, ma'am.
It is also resistant to chemicals, ma. Like a PVC only, it is also resistant to chemicals. But PVC is not stable to
Heat and UV radiation.
heat and UV radiation. It will undergo degradation. Okay, it is also strong polymer, but it is brittle in nature. It is brittle, means easily breakable. So that you write. Now tell me applications of Teflon. Teflon applications.
Gaskets.
It is having good electrical insulating property. Tell me applications.
Cables, wires.
Cables,
Gaskets.
wires,
Gaskets. Tubing.
tubing,
Non-stick cookware products.
non-stick cookware products, non-stick stopcock for burettes, chemical carry pipes. All this you can write, ma. Uses of Teflon. Okay, and these are the properties of Teflon. So students, when you are preparing itself, you compare and prepare PVC properties. Okay, Teflon properties, nylon 66 properties. So remember 5 points. After that, applications you write. Applications of PVC, applications of Teflon, applications of nylon 66, so that you can remember easily. Understood, ma? Okay.
Yes, ma'am.
Okay. Okay. Shall I end the class now? Hello. Okay.
Yes, ma'am. Yes, ma'am.
Okay. I'll give you attendance.